Okay, let's start with session 6 of our design pattern course. Let me remind you who I am. I am VP Lead Software Engineer at JP Morgan Chase and Next Revolut and Yandex, and my experience all about like my experience from my career, and it's about almost a decade of being backend software engineer. So I worked a lot with different languages, Java, Scala, Kotlin, JVM languages, but they had absolutely different features. So it's interesting how different patterns could be applied when you develop in these languages. And we also have Sonali, who helped me to deliver this course. She's senior software engineer for 14 plus years and specialized in building and scale e-commerce solutions. And we have Leslie, who started recently to work with Python, and before she worked with frontend a lot. And she also studied these patterns with all of you. So she helped us to build this content to be as democratized and approachable as possible. Let's do some refreshing on our last session. So last session, we discussed facade pattern and template method pattern. Who would like to share what is facade pattern? Okay, Pradna.
So facade pattern is a simplified interface that can be used by the calling method or class or whatever client it is. The aim is to hide a lot of other calls to different classes and just have the client calling just one call to this class.
Mm-hmm. Yeah, we can say also
Do
subsystems,
all
not
the
necessarily classes, but subsystems as
correct.
well. Yeah,
Yeah,
good
agree.
answer. Thank you. And who would like to take template method pattern? Yes, Barbara.
Um, yes, so it's when, for example, I think we had the example with making coffee or making tea. So you have two different versions, but many different versions, but they each do the same kinds of steps, and they all have the same kinds of functions. So, and the row of how you do the instructions. So first you boil the kettle, and then you do that, and then you do that. So what the template method does, it's just a recipe to say first you do this, and then you do that, and then you can put in anything you want.
Mm-hmm. Perfect. Thanks a lot. Okay, good. So today we are going to look at next chapters, and let's talk first about iterator pattern. Okay, let me know who thinks that they meet this pattern every day. You can raise your hand. Okay, Dennis, Isabel, Barbara. Okay, Pradna, Rachel, Deborah. Okay, perfect. I think you understood this pattern. Okay, so this is behavioral pattern that is all there because we basically implement some behavior to look at different items and objects. In our example, we had two arrays with different implementation under the hood. Which one is array and another array list? And the iterator pattern provides a way to access elements in aggregate object. Maybe like aggregate is good word to learn from this pattern. So basically we go one by one and find out which is next element, and we do not care what is internal representation of our data. I wanted to question you. What is wrong with the next code? Let me know. Okay, well,
Maybe because get menu items can return array list only of a certain type, and this type is menu item, and it's like not very scalable. What if we want to return an array list of some different type of objects?
well done. It's very good note about Java, like when you want to return method that can give you elements under the hood, you would like to use collection interface, which is, yeah, very good note, but it's not something that I would like to review here. Dennis, would you like to try?
I would say that the bold method is going to return the same. The first one is defining the array of menu items, and the second one array list of menu items, and its returns the interesting. The second one is type of array list. The type of array list is menu items and returns. They both return an array of list.
Okay. So my thoughts on it, when I see it, I trigger it like, okay, Pradna, let's try.
So, in my opinion, it's basically repetition of code, because both seem to be doing the same thing, except that
Mm-hmm.
that
No,
the,
but they are different
the
objects.
types are different.
If you remember the example from the book, they are from different objects. So they do not replicate each other, just one pancake house, our breakfast menu was internally implemented as simple array with squares, while like dining menu was implemented as array list. So it's different because it's just different representation menu under the hood from objects menu. It's different elements. The problem that I spotted is not about types. It's about that this logic allowed to return internal array of menu items, and basically anyone as a client can modify it. Yes, because they just give up in you. Like anyone could remove any element, add any element, clear the collection entirely. So for me, it's less like, hey, it's good point to discuss if you ever should do this. For example, in case of array list, you would do some copy, array copy. The same for menu item. It's more safer to give copy, not your internal collection. Do not trust anyone, your internal collection. Do copies instead of returning the one that you own. It's yours because clients are going to spoil it. Okay, I think I've seen something like, did you, someone asked something? They didn't spot who exactly. Okay, if you would want to ask something, let me know. Another way to Iterator, not the same as this book, but when my thoughts was like, okay, I've read this example in this book. I haven't been convinced that you need to implement Iterator to solve the problems that they had. What they wanted to print menu items. So basically they implemented iterators, but those iterators did absolutely the same thing as a regular list iterator in array list. So how I would approach this problem, I wouldn't implement iterator. And again, it's about that. pattern is just a concept, very good concept to learn, to know about, but it's not about that. You have to implement it by yourself every time when you met some problem. And one more thing to remember, these patterns were appeared when it was C, C++ languages, and some other old languages. And there was no Java, no Python. So it was very hard to program very complex projects. There was no microservices at all. Everything was monolith. Like 40, 50 years ago, they count ideas of pattern. And then it took them a while to decide which one is indeed pattern, which one is not. And at least 3 years to publish a book before like when they wrote the book and sent it to the editor. You keep in mind, maybe it took at least 3 years, maybe it took even more. So during these 3-5 years, already new languages appeared. So let's think about patterns again as a concept, and we should be aware about them. But in Java, for example, it's already implemented. You already have Iterator. And as soon as we just needed to print menu items, we could just copy them inside the array list, whatever collections they were represented for. There was third menu as hash map. But again, you could get these values as a list of values and put it in the same menu at the end. And then, as we already have Java 8, and this book was even wrote before Java 8 appeared, basically you can then do a lot of streams, like which one is back menu, which one is vegetarian, and which one is other menu, and then do much more powerful things, but just collect them in advance. So for me, this example in this book wasn't, I would say, can be like convenient enough to like, okay, I need to implement this pattern. So again, if you worried that you didn't have to implement this pattern, no worries. Maybe it's already implemented for you, like in Java, Iterator. In Python, the same, we already have Iterator. So instead of thinking about implementation of this pattern, I would ask you questions on Java language. So basically, there are 3 methods, has next, next, and remove. But if you use for each loop, what is going to be the result of this program? Anyone would like to try? Okay. Okay. Barbara?
I think, is it going to be an empty array list?
Okay. Who thinks that it's going to be empty array list? Raise your hand. Okay. Anyone else? Good, good. That's a result of this program. So, Ori, was it your, Ori, could you share if it's also your ideas? Because you said it will print only A. Okay, so no worries. That's you could learn through trying this example. And if you do testing, TDD, test driven development, or at least you cover all backtest after you implemented this, you could find this. No worries. Like if you do testing, you will find it in advance. You will run this program in your test in advance and you will find this error. The thing that when you reiterate through collections like this using for each, in Java at least, you already go through collection, and for this iterator, for these methods, it will not make any sense if you delete something, because if you saw example in the book, by implementing the iterator, you change the index doing plus plus, like you basically know what the index you are on right now, right? So if you just remove something, we would not be able to understand what is the current index, what is the next element. So that's why it's useful to understand Iterator. You don't have to implement it again in your production system, but you should understand what will happen if you will run this code. Yeah. Let's think about another example. Let's think we do not remove something, but we're going to add something, maybe at the same even index. So now we'll think what is going to be result. Okay, well,
Maybe it will just kind of create. It will create the same list because it finds the index of the current element and it just adds the same element on the index that this element was already there. So
Okay, Ori.
So maybe it will return an infinite loop. Probably because it keeps adding the current element back again to the list.
It's also, yeah, good note. Indexer. Okay, simple. When you will try to edit, it will give you the same, like, no, I going through this array, I can't change it. Like, no, we are not going to change arrays that we are reiterating right now through. Like, for each method wouldn't allow you to do this. So basically, you will see A, you will see first index of A, which is 0. And then Java will say, I'm not going to do this. Because the method that's under the hood in array list implement for each method. You can check, if you use Java, you can check after this lesson by yourself where exactly this exception is coming from, because there are exactly lines that explain you're going to change collection, but right now I'm looking at the index and I don't know how to iterate if we change the index, so I just can't. So concurrent modification exception, that will be exception that they say you're trying to read, iterate, but at the same time change. Something like you try and do different concurrent methods, and that's why, no, I'm not going to do anything next. How to solve it? Use iterator, use functions next has next, etc. So if you will get the iterator, if you put there while we has next, we look at next, and then we can try to something. But I'll put it as your exercise to practice. Yes, Sonali?
Yeah, I think my question was around that, like how we would actually fix it. So either we can again convert these array list to an array and just get the index of the string and then replace it, or the other way around would be an iterator, right?
Iterator, yeah, because for each already use iterator, manage indexes, etc. But when you get the iterator by itself, you're safe. I would give it to you to exercise to check if I am correct.
Yeah, maybe something that we I'd like to explore as well, because what would be the optimized solution. So generally we would encounter such issues in production code as well. Like you have an array list, but somehow you want to identify a particular uh, position of an element, and then most of the time I think I've seen the code that they convert that array list into an array and then do a for each and then try to get the position. So it's interesting to evaluate whether in that situation going via the iterator or via the array, what would be beneficial.
I think again, iterator, like you can use break in for each.
Yeah.
It's antipathic. But if you need to do, for example, paginations that we are going to talk today as well, just in a few slides, you need first 100 elements, for example, and you need to break into your for each loop to give them, where you still can use for each loop. And in this case, you say, yeah, basically, okay, you can do it basically by for each loop and do the break. Yeah, you could return from for a cycle. You actually, if you look for position, you can just increment variable inside cycle and return when you reach the position that you needed, or element that you needed. You will interrupt the for loop. There are a lot of there could be a lot of shifts instead of going through copy the whole array, especially if it's a big one. And again, if it's a big one, if it's million of elements, that's the case when we will think about iterator, because we just maybe can't get everything in memory. But let's go next to other examples. Let's consult with our group patron and see what examples they have. First of all, they explain the problem like you have tree structure, and there are two things to iterate trees: depth first search and breadth first search. And you can ask in our lead code group, what is it? Because it's something that we can practice in lead code study group as well. Basically, there are two different ways to iterate through tree. First is we going by element by element like this, and second like this. When I look at it again, if tree is not big, I'm thinking, why shouldn't I just copy this tree to array list and then use it later? But if we think that we have very big tree that we load in memory from database, it's maybe it's very, very costly for us to go through this, to copy this tree. So maybe in this case, we need indeed to go to this iterator. Did I have to do it in production? No, not sure. I had some structures that was hard to iterate, but it was more like still use some basic methods how you iterate through trees, like look at the next node, for example. And let's look at another example in Java. It already remembers the page where I stopped. So it's let's go iterating over social network profiles, where we have profile iterator, again has next, get next, I would say just next, not necessarily get. It has reset because it's a manual profile iterator, so you can implement your functions. And what is the big difference? The example that we looked at in book, that when we go and actually do iteration, we use lazy load, which is mean we basically first request profiles from Facebook. And the same will be for LinkedIn in the implementation of this social network. And that's important because That means you couldn't just get and copy everything in array list. You could only do it for your own custom iterator. It's more like performance engineering and working on, I would say, high load systems. Again, would you meet this pattern? I won't guarantee. But looking at it, looking at these examples, you know, like, okay, if you have performance issue and you need something very interesting to solve this issue, and you need to iterate elements, but do not load everything in memory. Even when you already requested profiles, already went through them, Java machine doesn't need them anymore. They could just clean these objects, and you might feel safe and being on lower memory. Yeah, so that's interesting case where it makes sense to go through Iterator. I also would note here that popularity, as you noticed, you use this pattern every day, but it doesn't mean that you implement it every day. And to implement it by yourself, we finally met at least one pattern that has complexity more than one starlet, 2 or 3. Yeah, another one that we've met was decorator pattern. At least for decorator, I remember it was also 2 or 3. So now we know about a good example for iterator. If I look at Python example here, I wouldn't say I really like this example. However, it shows you that it's different to Java, and it's also show you which methods in this case you need to implement. In this case, you need to implement iterator interface, the same as in Java, the same name of the interface, which is abstract class, because they don't have interfaces. And here you say what is your init for this iterator and what is the next method, how you look at the next element. So they propose 2 options, go one by one or do reverse. So in this case, you also have reverse. That's his example, but we have another one as well. Let's see. So let me continue with my presentation. So again, you need to implement different methods. For iterator itself, you need to override next method. And as soon as you have no more values, it's stop iterator, which is again different to Java. And then the objects that use this new iterator, they need to override iter method. So that will be the difference. Python also has something as yield keyword, which allow you to create generators. And here I have a question for you. For testing purposes, have you ever used data generators? There are also the way to do this for Java. Okay, yeah, Dennis used it. Okay, Barbara used it. Good. Well, used it as well. And yeah, Rachel used it. Okay, so that's something that in Java you can use strings to generate values from range, but in Python you have yield I, which is, I think, cute as a person who looking from another language on this language. And examples that I will share as well. Iterators that give you only even numbers. And as I said, I didn't have to implement iterator in production, but there was an interview once upon a time when they asked me to implement in Java iterators that will look only on odd indexes. So that will go through collection and will give us odd indexes. So it was important to understand how not to mess with has next and next method. I did it, but it was hard, to be honest. And I knew back then already what is the iterator as an interface, what methods it has. Still, I would say it needs to be exercised a little bit to not mess with like which is has next and which is next, and how not to like do the work twice when you do next and has next, because when you do next, you always check has next, at least in Java. So here is similar example to exercise. It's looking at even numbers only. Another interesting idea that I found that you can also work with generators, something like you generate the next element, but you basically connect, do this generation, you check like which one is next one, which is Fibonacci, like it could be infinite elements collection, right? Interesting. So there the iterator will make sense again. More like a fantasy example, but still you can think about cases and you can memorize. And yeah, one more thing, reverse. But again, what I really did like that you do this very simple by using this concept of iterator in Python. If I think about system design world, I can only imagine that we can compare it with when we can't give all data, for example, for mobile app or for web app, we can give only the page, yes, or pagination. And in this case, you can think like, okay, we basically limit our data. So we iterate through pages, but on the bigger scale. So that's how you can think about system design in this case. And again, question for everyone who joined us today. Have you worked with pagination in production systems? Okay, yeah. Yeah. Especially if you work with front-end systems as well and full stack as well. Good, thank you. Another thing that I can compare, it's interesting. It's about libraries, frameworks, big frameworks where you work with data. Again, you iterate through them step by step, and you can think about it on the level, low-level process for each cycle, and you say which iterations to do, like step by step. Yeah, but instead of iteration, you have these blocks that transform your data. Basically, it's also more about streams analogy, streams API in Java. But we can think like streams also iterate in other interfaces. So when you do transformation in, for example, Apache Airflow, it's something like you iterate through data, but instead of for each cycle, again, you do these blocks. And again, question, have you worked with Airflow or similar frameworks before? Is there like anyone who at least aware that in their company, they use Airflow? It's not like, it doesn't even necessary that you work with it directly. Okay, thanks, Rachel. Oh, thank you. Great. Have a plan. Okay, yeah. Good insights. Okay, I didn't ask again because most of you said that they already understand that they see this pattern every day. Let's go to Composite. Now we go to another structural pattern, which again, if you think about structural patterns, we do not create new behavior. We do not think like, okay, we have some behavior, how to pattern it. We think like, okay, we have some structure, how we could do it through the pattern, how we can make it a little bit more interesting. An example from the book, I think it's, for this pattern, it's a good example because it's a menu. It's indeed when you come to some restaurant, you can have dinner menu, lunch menu, but also they could could include exclusive chef menu. Drinks menu could be separately, and inside drinks menu, you can see like summer drinks menu or like hot drinks menu. So we did a lot of sub-objects, even more than one. And what they wanted to do, they wanted again to print them, print menu. And composite pattern indeed works very well here. It's allow you to compose objects into tree structures and represent this hierarchy. It has quite simple client class diagram. And if you look at another example that I liked, because I would say it was more hands-on example. This is about how to calculate size of objects around. I also, just for curiosity, tried to find how it looks like when you use bash scripting here. In bash scripting, you would have to check if it's directory or file, because you basically don't have hierarchy in bash languages, right? So you can't use this pattern. You would have to every time check what type is it. And you need to implement it in a more direct way. You need to code more, basically, when you do bash scripting. Despite bash is like less abstract, less high-level language, you would write much bigger scripts to solve this problem than you would use Java. So again, we use storage as calculate size, and that will be our component. Yeah. So here in this example, it's storage. Then we have file, which is storage, which is our leaf. I share this example because for me it was easier to memorize this pattern through exactly this example. It makes a lot of sense to me. And then we say we have directories, folders. They are composite because they could use inside files and folders again. And we say we already said that we need interface as storage. And it's very simple to memorize because, again, we just want to calculate size of our files, etc. If we would want something else, maybe we would do another interface because, as you remember, it's better to have different interfaces that's solving for us different problems. So when we do size for file, we just use size of the file. While when we use size of the folder, we know that we need to check every child from our children, and element calculate size, which is mean if we go to another folder, we will check all files inside with another folder and we'll return them. It's indeed how we do operations on data structures S3. Like if you need to, I don't know, think about tree and how would you solve the problem of calculating the size of the tree. You will go to each node. If it's bidirectional tree, you will not just go through children, but you maybe go left and right and do recursive calls. So here it's the same. It's basically recursive calls. That's why we say about composite pattern is something that give you tree-like structure. Indeed, because you do recursion now. You go to child and you execute method from them, which will be return size. And client quite, we create several folders with different levels, and then we can find out which level has which size. It depends on files inside. So that's a very good example. I would encourage to go through this example to memorize it and think about, okay, again, if you even never ever would have to implement composite pattern, at least this example will give you an idea, okay, what this pattern about. If we have it in Java, yes, we have already implemented for us. Let's go just quickly here. So I put several examples. okay, I put here Java implementation, but in this one, it's C++ implementation. But again, indeed, if you need to parse HTML and you want to say, actually, I work with different tags as the same object, then this example will be helpful. Let's go to our group patterns and let's see what they say. I think their example also makes sense because it say we could have boxes and inside box it could be product or another box with products. And if you want to calculate price, it's very similar to like we want to calculate size of file or of storage of folder, size of folder. So the same price of box, which could have inside products, but boxes, other boxes that could have inside other products. And that's we wrap into containers, Docker containers, and ship. Okay, I'm joking a bit. If we go to Java example, I've looked at it for a while. And yeah, before, let's also note that we already saw some patterns. And again, to think even more and twice about patterns, look at relations when you look on this website. Builder, I would say no, because we actually implement Builder in a bit different way, not the same way as Composite. But for Decorator, I like this example because it's a basically Decorator is the same as Composite, but has only one child component. And when I memory, like when I think, okay, what was Decorator? Looks like yes, it has just one child, and you build again the tree, but this is like the tree with only one branch, long branch, and you go down to bottom through this tree. So yeah, indeed, we can think about Composite as a bit similar to Decorator, a bit more complicated. Let's go to Java examples, and I really want to go through with you for all patterns, and then we will have so many patterns to compare. This example says that let's work with shape as an interface, and we will have even an abstract implementation to simplify our computation, but then we will say we can have dots, circles, rectangles. And let me jump quickly straight to client, because what we can do, we can build shape itself, but we can build compound shape, which has several shapes inside. And then we can work with it as compound shape. So let's look at compound shapes. This is circle, this is very simple one, but this is like we said, we can do now smarter. We can do both at the same time, circle and dot, or rectangle and dots round. And what exactly methods that will be executed? It will say compound shape. So the most interesting thing now, how we would find what is a X for this shape, yeah? So we basically will find out as a rightest, yeah, the left is the most left one, because then when we say Y, we say about the lowest one. I would say actually the highest one. So we can say this is the left one, this is the most left one, this is the most highest one. That's like somewhere here, like our shape. Yeah, I don't know why they pick up the smallest one. I don't agree with it. But the same for this and height. You basically trying to find out what is the one, and you trying to find the max height. the same like the max width. Yeah, so basically you're trying to say like, okay, this is complex, as this is complex shape, and we still will say what is the depth, what is the height. We move them, and yeah, interesting that we can check if something inside bounds of this even complex shape, and paint, which is the most important for us to paint with. Yeah, so this is another example. Again, I'm not sure where you would need it, like would have to implement something the same in production. However, to understand this pattern, I think it's a good example. Okay, if you go to Python, again, here it makes you to look at a bit more abstract example. They even use leaf and composite, which I don't like. That's why let's go to our presentation. So as I said, composite and Iterator. It's interesting to compare. But now let's think how we would use it in Python. Let's do the same. Let's do file system. We have show details as a method. And directly, so basically we said that our component, file system component, our leaf is a file. Our composite that have children, it's our directory, yeah? So we basically have contents and then we add or remove files. And as soon as we're ready, we show details. Okay, we can achieve it in Python. I was thinking twice about it, and I was thinking what could be different for Python, and I found what could be different. Python is a language with dynamic typization, and that is why it easily allows you duck typing, which is not the same as dynamic typization. But if your language is dynamically typed, you can think about this duck typing concept. So what is it? It is behavior implemented by object regards the type. Like what we think about, like if it's methods that have a duck, it's probably a duck, but we don't care. While in Java, we have very strict typization, static typization. We can say it's swim like a duck if it doesn't have interface of duck, of swimming. And in Python, we can do this. We do not check what is interface, if this object has this method and doesn't have. We just allow to invoke it in our code. And in runtime, we will see, I would say like this. Let's check in runtime what's going to happen. So basically, we can say we just have file without any component, and it has method show details. And we have directory that has the same add, maybe remove, but it doesn't matter now. It has details. So what we are simplifying, we do not enforce them to be implementation of this storage interface. Yeah. And it will be absolutely the same when you will run it. Runtime, code the same, output is the same. The only different, because duck typing is learned, we didn't force any interfaces. So let's think deeper. What advantages? Okay, that's simple. Now one more file with component. It's less simple because we just edit it. It's straightforward design, but we don't have anything to force with. So basically, if we invoked it from as a method, from as an object that doesn't have show details, we will have an issue in production. We sacrifice scalability, we sacrifice extensibility. Now let's remember, like, why we use design pattern? Because we want in the beginning to make our programs to be more maintainable, robust, scalable, and extendable. That's why even we could not use this pattern in Python. I would highly recommend to use this pattern if you need this. I would highly recommend to use some after classes, etc., just because then you could give a bit more guarantee. You could give a bit more explicitly that, you know, this object that have this method. Yeah, another thing that I was checking, we was talking in this course about list of substitution principle. And if you think about deck typing, yeah, basically the community says that it's not about violation, it's about different way to look at risk of substitution principle, which is mean you think about expectant behavior, right? So when we meet risk of substitution in Python, from the community perspective, it will be different concept, different to Java, because that there are no like forced inheritance in Python to have the same methods. However, again, why I would highly recommend to use inheritance, because you will avoid problems in runtime. Yeah, and you could do mistakes in typo. Even here, like if you say one show details and one show detail without S, and we think, okay, client will work. Yeah, but then we will have this accidental typing errors, which is not pleasant at all. And you are like giving implicit contracts. You do not give them explicitly. Yeah, so it's risky. I just put there languages where you could do this. And Python, Rust, Go, JavaScript, PHP, Perl, they all will allow you to do that typing. I will read some comment. This is what I use in TypeScript. I force contract interfaces types. Yes, because TypeScript, it's extension of JavaScript, but it allows you to say what is the type of this variable much more strictly. So yeah, it will make life much easier. So I respect that you use it. Okay, so that's all that I wanted to share with you today. We looked at Iterator and Composite. We still have journey ahead. It's 10 at least sessions. We'll see if we would want one more, but according to my schedule, we even will be able to cover everything. And we will find this presentation a Slack. And thanks a lot. Now we are open to questions, and I will wrap up the sessions anyway. Let me do this quickly.